In this video, we do a durability test on Eastwood's Rust Encapsulator Platinum. Stay tuned. Welcome back and/or to the channel. Today we are doing a durability test on the Rust Encapsulator that I installed on this frame about a month ago. I have given it enough time now for it to be fully cured. Even on the stir stick, there is nothing soft. This is a very hard coating, very hard to chip off. We're going to do our first tests on this actual stir stick actually, and we're going to see just what it takes to get it off of this stir stick. We're going to see how easy this material is to scratch. We're also going to see how deep we have to dig, or if we have to break a piece of the wood to get this off. Now, I do know from doing the ground cable that a grinder with heat and friction removes this stuff very rapidly. So if you ever have a spot where you need to get this off, usually a little bit of heat and this stuff will come right off. Now we will test the heat factor of this as well. But with this, I'm going to be making my final decision on if the Crimson 5.7 frame stays silver, like you see over here, or if I'm putting the bed liner on it. And that can is right down here. Now, the thing is even if the frame stays silver, I still need to use the bed liner underneath the frame of the truck on the floor pans. And the reason I'm doing it on the floor pans is I need to come up on the rockers a little bit so that I don't have rock chips chipping off the paint and causing spots where rust is going to happen. So the only way to do that is to put that bed liner in those spots. Now I could rust encapsulate the whole thing, but I think having a silver edge across the bottom of the truck might be a little too distracting. So I'm going to opt to go with the bed liner, which is going to be black. And that'll hide and blend a lot better, and I'll have a lot less issues with rock chips. Now, if I ever get into a situation where my running boards come off, then I'm going to probably put the bed liner on the underside of my rocker panels. And I do have the two-wheel drive tank in here to show you why that's important. So where I would do this is on the underside of here. And what that does is so that when rocks come off your tires, they don't come up and hit underneath here. Now it can save the bottom of your doors as well, but usually your running boards do that. Here is a prime example of what happens when you have tire kick up and you have nothing to protect you. This basically just all rots out. And yes, I did spray foam this. And the reason that this looks so chipped and chewed up is because of that exact same thing I just told you. Tire kick up. And the only way to prevent that is to put a harder, more durable coating on the underside of your rocker panels. Because rust happens two different ways on rocker panels. The first way is you get dirt and debris that builds up inside the rocker panel, and that moisture gets held in there from all the sand, the gravel, the dirt that gets left in there. Now, you could wash it out every couple times a year, maybe twice a year, wash out your rocker panels, but then you also get an issue where you're trapping moisture in there, and there is pinch welds in there. So the way that they put these together is you have multiple layers of metal all sandwiched together, and then there is an electronic device that pinches on to all three of those pieces and welds them together. What that does is create a burn spot. That burn spot has no primer and no protection, and this is done from factory. Now, because that is that way, what happens is there's no protection there. So as water gets in between those two pieces of metal, as moisture gets in between those two pieces of metal, they start to rust. Now, you could block off all the holes on the underside, and this one was done this way. There is actually blocks on it that covered off those holes. And what they did is they used Gorilla Tape. Easy thing to get your hands on. Anyone can put Gorilla Tape on your rocker panels and you won't have the moisture and the dirt and debris getting in there. But if you don't keep up on it and you don't replace it when it starts to tear off, it's not going to do you any good, because once it's in there, it's in there. And what happens is the rocks and everything just keep rubbing against those two panels until it creates a spot where moisture can get in. Once moisture gets in, then all of a sudden the rust starts. Well, then once the rust starts, it just starts eating away. And that's what happens to rocker panels. That's what happens to cab corners. That's what happens to your bottom lip of your door panel. Crimson 5.7 has a little bit of rust on both door panels on the back doors. And some of this is from the kick up from the front tires. And what happens is it chipped away at that front edge or the back edge of the door right on this bottom lip. Now, the only way to truly fix this is you could do a sectional panel across the bottom to fix the rust. And then you'd have to repaint the lower, or you're going to have to put a whole new door skin on. And as long as this lip isn't destroyed when they go to take this apart, you could just put 2 new door skins on. And that's kind of the route I'm thinking about going. Another area that gets extreme amount of rust is right back here, right up on your box sides. Crimson 5.7 is absolutely destroyed because of rust. And this is why I did the rust encapsulator and why I'm talking about it before I do my durability test. Because this is the whole point of us doing this project, is if this stuff doesn't stop the rust, it's not doing any good. And that's just the honest truth of it. I mean, that's why we go through all this work and time and effort and to do these projects, is to make sure it's going to hold up. And nobody's really going to know that until you do a long-term test. If you do a long-term test and say, hey, I tried it, it doesn't work, then you can say that. There's times I've tried repairs that, 90% of the time it could be the problem, but sometimes it's not. You just got to keep going through your process of elimination, going with the most reasonable thing that makes sense. And that's how most mechanics nowadays do it, because if a computer doesn't tell you the problem, it's trial and error. But this is a prime example of wheel wells that rot out because dirt, sand, and debris gets wedged up in here and just rots out this entire lip. Now this lip is supposed to be right down here where I'm running this. So this big massive rust hole, it's just gone. There's nothing there. This panel is barely held on if it wouldn't be for this top edge. This top edge, 2 brackets underneath are all that's holding this panel on. And then this front leading edge, that's it. This whole center section is gone. There's nothing here. And that's why I said, as far as this being something I'm going to mod out or something I'm going to do something with 312,000 miles and rust in the shape that it's in, nope, I'm going to keep it running. Keep it running, and when it dies, we'll replace it with something else. We'll have to see kind of what that's going to be or at what point that happens, but that's kind of where this is at. So I think we're ready. Let's get set up. I'm going to show you what I'm going to use for tools to do the durability test on this. And then once we've done the durability test on this, we're also going to try it on a section of the frame. Now, if it comes out fine, what I'm going to wind up doing is recoating that section of the frame, and I need to do touch-ups. So when I do that, I'm going to do the touch-ups at the same time. Now, the reason that I'm going through all this is I want to decide, do I want to leave it this color, or do I want to go with the black frame? If I want to go with the black frame, then I need to bed liner everything that I've already put rust encapsulator on. If I feel that this is durable enough, I like the silver frame, and I've taken a poll among people that I talk to in my daily life that also watch the channel, and they like the silver. They think the silver really stands out against the frame. So that's the only reason we're doing this durability test, is to find out, can I get away with it? Is it durable enough to last over time, or will it chip off? So let's get set up. Okay, now that I'm set up, now we can start doing our durability test. And what I have here, I'll show you everything on the ground here. I want to keep some of this stuff out of the way because it's not part of the test. But what we have here is We have a few different solvents that we're going to try to see if it breaks down when it's put on there. Got our paper towels. We have a heat source to see how quickly it burns off. We have a screwdriver, hammer, and a punch, and a razor blade. Now, obviously I said I was going to try this on the stir stick first. And the reason I'm doing it on the stir stick is if I wreck the stir stick, I don't care. If I do a big chunk out of the frame, it's a lot of time re-prepping, repainting, re-everything. So, I'm going to try it on here first. If I like how durable it is on here, we're going to switch over to the frame because I want to see if there's a difference between the wood and the metal. So, first test you want to try, and this works with any durability coating. You can do it with bed liner, you can do it with anything. But what you do is flat screwdriver. Flat screwdriver, all you do is just try to carve it out and see how soft it is. See if it peels a bunch out. Now doing that, I did leave some pretty decent gouges in it, but it didn't look like it went all the way down to the metal. So I did 2 of them right here by where my finger is. I'm going to do one more deep one, and this is with the edge of it, and I'm going to go straight down. Again, I don't think I penetrated, and it didn't blow out or peel out. And you can definitely see how deep that I went. Okay, so first test, and this is the reason why I want to test it on metal, because wood will deform when you put that much pressure on it. Allow me to show you. So, when you put pressure down on it, you'll deform the wood. And I need to know, okay, is the coating deforming down into the metal or into the wood? Or is the material actually getting peeled away? And that's what this next test will tell me. Next test is going to be the razor blade test. Now what I want to do is I want to go on top of where this is, and I want to try to scratch some of this off. Basically, I want to cut a chunk out of it. And remember, always cut away from yourself, not towards yourself. What you're trying to do is remove a chunk of it. Okay. Okay, so here I was able to use a razor blade, and I was able to get down to the actual wood. What this tells me is that it can be removed fairly simple with a sharp object. This would simulate a stone or something sharp that you would run over. And if it will take a big chunk out, then you got a big problem. Sharper the razor blade, you have to determine how hard you're actually pulling across the material to actually remove a piece of it. Now, when I just grab it and slide the blade, it actually slides for the most part. It doesn't just take a big chunk out. In order for me to get this little chunk out that you saw, I had to, you watched me, but I literally had to sit here with my thumb and pry against the wooden stick and go underneath the coating. I had to work at it. And that's pretty decent for a coating. I mean, bed liner would do the same thing. If you really focused on it, you could chip it off with a blade, but if you were just skimming a blade across, it won't do anything. So right now I'm seeing a lot of things that are very similar to a bed liner coating at this point. Alright, next, what we're going to do is a hammer test. And what the hammer test will tell us, and I'm only going to do it on the end of the stick because I do want to save this as a stir stick yet. What the hammer will tell us is how bad the material can deform before it starts to chip off. Or if it won't chip off and just deforms down into whatever it is. This will test the elasticity of the material after it's been under pressure. So what I do is I take and set it down on the ground. Okay, And we did get some chipping on the tip. I'll show you here. But for the most part, all it did was deform the wood. So right here it deformed the wood. And up on top, this edge here, you can see where it's flaking off right there. So as far as impacts go, because the wood stick is so soft, I'm going to take the educated guess at this point that the reason that this flaked off on the end is because the wood is so soft that when it crushed, it just flaked off the tip. Last thing we're going to test is, well, last for the physical tests. What we're going to do is test the punch test. And what the punch test does is basically tells you after the material has, or the panel has been seriously deformed, what does the material coating do? In this particular instance, it does crack it slightly, but the material actually stays in the hole, which is surprising. Most of the time you would have this and it would blow out or it would chip out a big chunk of it. It wouldn't just deform like that. So far we're seeing a lot of good things. This is all stuff that would be indicative of having a bed liner. I mean, it's the same. It would scratch the same. It would perform the same. It has that same hard coating on it. I mean, this coating is extremely tough at this point. But what we have left to figure out is what causes this material to actually fail. And one of the biggest things that could cause a material to fail, especially on a frame, is when you're doing a brake job and you spray down your rotors, you spray down your brake parts, you're using brake parts cleaner. Now we're going to step it up though, and we are going to use a carburetor cleaner because carburetor cleaners can be a little bit more harsh. And I want to see if we have a material fail due to chemical reasons. So now we're on to chemical issues of why we would not leave it raw like this. And what we're going to do to test that is very simple. We're going to start with brake parts cleaner because this is the most common. If it fails with the brake parts cleaner, but if it doesn't fail with the brake parts cleaner but fails with the carburetor cleaner, I'll still probably call it a success. If it fails with the brake cleaner, I've got bigger issues. So how to test this: spray some into a rag. You're going to pick a spot that you haven't done any damage to it, some place that's clean yet. And then you're just going to start rubbing on this. Rub on it for about a good 30 seconds to a minute, whatever you feel is safe. And then what you're going to do is check not only the stick, but you're also going to check the rag. And what you're looking for is for it to rub off the rag. And I don't see any, but we're going to go ahead and do a 1 minute test. Now, a 1 minute test would simulate a lot of lifetimes on the road. And this would simulate pretty much wind or anything else that would potentially happen that would cause friction on the frame. And with the chemical part added to it, this is basically years of damage right here. I mean, this could be the better part of 10 years worth of damage. And like I said, you want to go, your toughest test, you want to go for about a minute. And it's actually starting to rub through the paper towel. I got a little stopwatch on my phone. That's what I keep looking at. Okay, it's been a minute. Coating is not soft at all. Nothing wrong with it. Paper towel has a hole in it. from where I was rubbing. So, brake test, brake parts cleaner test. You can spray this stuff on a frame that's had rust encapsulator put on it. Perfectly fine. Not a thing wrong. Next, we're going to step up to, and now you have to pick a new spot and a clean part of the rag. But you need to go in a different spot to test the next part because you've already done decades of damage right here. So it's not fair to do the same test right here. So I'm going to come down here on this one. And on the WD-40 test, we're going to go in a different spot. And if you don't have a clean spot on the rag, just so you know you're getting the best test results, grab a new rag. So, fold it over again like I did the other one. Okay, I got a very nice amount on there. So what I'm going to do, same test, 1 minute long. So, here I go. Okay, there we go, 1 minute. Again, not soft. It's still very durable, very hard. Rag obviously has a rub hole in it. So, I got a feeling that the WD is not going to do anything to it. I really don't. But, what we're going to do, I'm going to try it on this side here. And this is simulating worst case scenarios and it's showing long-term durability. All it did was shine it up. That's all it did. I mean, I probably won't be able to pick that up, but yeah, all it did was just shine it up a little bit because it added lubricant onto it. No, it's perfect. We can't ask for anything better than that out of a product that is obviously made to block rust. And this has really kind of given me the answers that I need as far as whether or not I want to leave it the way it is on the frame. Now I am going to test a few spots on the frame, and I have done some testing when I did the ground cable, which I will show you. But the last test is a heat test. And what the heat test is going to tell me is how much heat will this stuff take before it starts to melt or come off. This part you want to be careful. Be near a door or something like that so you can throw it out of your garage in case it does burst up into flames. Try to keep the stick up. That way the flames will go up, not down towards your hand if you're holding it like this. But all we're doing okay. That little bit of flame told me exactly what I needed to know. And this is what I thought of when I did my ground cable. Just that little bit of heat has ate right through that coating. Okay, we couldn't scratch this coating. We couldn't hammer on this coating. We couldn't take a punch to this coating. It still held on, still did what it was supposed to do. We took a razor blade to this stuff. But the minute that you threw a little bit of heat to it, this stuff just disappeared. And this will be an issue if you're anywhere near exhaust headers. It will be an issue if you're near anywhere that you wind up getting an open flame on it. If for any reason your ground's short out and you have an electrical fire, this thing's just going to burn right off. And at that point, you've got bigger problems, but at the same time, it's going to get toxic. And that's something that you'll need to remember, that if you go through and do your vehicle frame coating and all of a sudden something happens and the vehicle's in a garage fire, or somehow you get a fire, brake fire even, where you get a brake that locks up or a wheel bearing that locks up and it starts a fire, this coating will burn off. And I'm pretty sure that the chemicals that come off of this are not safe to breathe. The little test I did, I'm okay because it was able to disperse away from me before it got to me. But if you're dealing with an entire brake fire in a wheel well, that's a bigger area. A lot more toxic chemicals are going to be coming off of that. So just be aware of that. But that being said, this happened on open flame, not on something that just had heat to it. So if you were to put this on a header, obviously it's going to burn right off because that header is on direct heat source, so it'll burn off. But on a frame rail where you're a few inches away from that exhaust manifold, it should not burn or melt off. Now that's something we're going to keep an eye on, because I did coat the inside of the frame on the Crimson 5.7 here. And we are putting headers in here. So when we put headers in here, we're going to be generating a little bit more heat. Now we are about 3 to 4 inches away from the frame all the way around, wherever the header or exhaust is going to be. But if we start noticing that the coating is failing on the inside of the frame by the exhaust, then we'll know that this thing has a very big vulnerability to heat. And they may have designed it this way on purpose, because if you're ever trying to remove material, you need to know how you can easily remove it. Obviously, we can't use a razor blade. We can't use chemicals. So what are we going to use to remove this stuff if we ever need to? And that might be something that they thought of when they did this. Is, okay, well, what if we make it easier to remove with heat? And that might have been their option. Now, after hitting this with heat, this became very soft on the tip. And that tells me that this stuff does not like heat. So, something to keep in mind. I'm not saying it's a deal breaker for leaving the frame silver. I like the way it looks. In order to generate this much heat, I would have probably given myself second degree burns in just that short period of time. So, that being said, coating didn't do all that bad. And it was open flame, not necessarily an indirect heat soak source. Your frame could get heat soaked by your exhaust. That's obvious. But it should not get open flame. If it gets open flame, then you got an exhaust leak close to your motor, which you should fix that. But I think I'm going to get ready here to start trying this frame. Now what I'm going to do in order to test this frame is I'm going to switch you around, and we're going to do some of the similar processes only on metal. But let me get you set up. Okay, got you set up where I want to be. And here's where I did one test with a screwdriver. And the reason I did it there is because it's easy to fix. It's an easy spot to paintbrush and replace. So what we're going to do is just do the hammer test right here. Okay, this had flaky rust here, so I'm not blaming the rust encapsulator for that one, because it did fall off in one big chunk. So what I'm going to do is I'm going to go over just a little bit farther to right here. Okay, as I was hitting, I'm deforming the metal. I'm not wrecking the bed liner. Or, sorry, the rust encapsulator. So, the Eastwood Rust Encapsulator is holding up great right here, where it's bare frame, no flaky rust. And they do say, make sure you remove all flaky rust, which I have attempted to do, but it's really hard to. And I was hitting on this pretty hard to get that to flake off like that. But this spot is easy to touch up. Like I said, it's not a big deal. I can go right back in, touch that up, and that won't be an issue. I mean, I'm hitting it pretty hard. So, I mean, obviously I'm not coming up here and going. And even that, I mean, I'm wailing on this frame with this little hammer, and I'm not going to dent the frame, obviously, with this small hammer, but I'm not really blowing off big chunks like you would see with other products. The other thing I want to test is how well this stuff scratches off. Okay, getting a little bit of black underneath, and that was me digging. Now, I'm just going to try a light scratch. It's not doing anything. Okay. I'm not going to try flame because this, I had done the grinder to it, and it had removed material from this outer edge that got warm from the grinder. So I'm not going to go after this with a heat source. It's obvious that the ground had, when I did the ground, that just the grinder, the heat from the grinder ate away at this coating very rapidly, which was an indication of the blowtorch test that we did. The last one I want to try on the inside here is going to be the brake parts cleaner. And what I want to see is, now that I have a spot that's chipped off, does this get underneath the coating to where it flakes off easier? Just tears through the rake faster. Nope, we're good. So, what I'm going to do at this point is I'm going to call this test a success. I know this video is going to be a little shorter here than what I have been doing lately, just because I've had so many projects that I'm trying to get done. What we're going to do is call this frame coating a success. I'm going to go ahead and finish my touch-ups on it. I'm going to get this frame ready to start putting stuff back together. Now, we do have a header project coming up on this truck very soon. We did an unboxing for BBK headers. What I plan on doing is I will link that unboxing in the description down below. But I will have a friend here helping me with this, because what we got to do is heat it up and take both sides loose at the same time, because it is very time sensitive in order to get everything out of here, in order to be able to get this apart, because you have to do it while different parts are cooling down at different temps. And in order to do that, we're going to have to pull this apart basically at the same time. So one on one side, one on the other. That's what it's going to take. And we'll let you guys know how that works out. If it works out great, then I'll give you kind of a lowdown on how we did it that way. If we think, hey, we probably could have, one person could have probably gotten this, we'll let you know that as well. So if we get to it and go, well, hey, that blew apart real easy, you know, let's see what happens if we give it a little bit more time to try to take the stuff apart. So we do have that coming up very soon. Like I said, I need to finish touch-ups, which I may do today. I want to untape this entire frame, get everything untaped, and start getting everything put back together. So next video, I'm probably going to be prepping parts. I'm probably going to be prepping frame, and I'm probably going to be doing touch-ups. So, but that's what we have to look forward to. I'd like to say thank you for watching. Please hit that like button, smash that subscribe button, and I'll see you on the next one.